Hi guys, in this lesson we're going to talk about solutions of linear equations. What are linear equations? A linear equation looks like any other equation. It is made up of two expressions equal to each other. And this is an example, y equals negative 2x plus 6. Now what makes linear equations special is that it has one or two variables. And in this example, we have two variables. We have y on one side, we have x on the other side. And what also makes linear equations special is that no variable has a power greater than 1. In this example, we have y with a power of 1, x with a power of 1. So no variable in this equation has a power greater than 1. That's why this is an example of a linear equation. Now, the solution for a linear equation is a point of x and y of two coordinates, the x coordinate and the y coordinate. That makes the equation a true statement. So the solution of linear equations is a point and not just one value. Now let's take a look at our first example. We have the same equation, but we're going to evaluate this equation or linear equation when x equals negative 2. And to be able to evaluate this linear equation when x equals negative 2, I need to substitute x with negative 2. So when I substitute x with negative 2, I get y equals 10. That's why the solution for this linear equation when x is negative 2 is negative 2, 10. Now let's evaluate the same linear equation, but this time when y is equal to 4. So in this case, we're going to substitute y this time with 4, and we're going to keep the x and try and solve the equation for x. So I'm going to end up with 4 equals a negative 2x plus 6. I'm going to take away 6 from both sides. And then I'm going to end up with negative 2 equals negative 2x. I'm going to divide by negative 2 on both sides so I can isolate the x. And x in this case is going to be 1. So the solution for this linear equation when y is 4 is 1. Now let's talk about intercepts. We have two intercepts or two kind of intercepts. The y-intercept or the y value for which x equals 0. And we write this value as 0 and y, which is the y-intercept. And the second intercept is the x-intercept. And the x-intercept is the x value for which y equals 0. And we write the x-intercept as x or a number and a 0. Now let's take a look at example 2, where we are trying to find the x and the y intercepts for the linear equation that we are working with. So in this linear equation, I'm going to try to find the x-intercepts first. So we know in the x-intercept, the y value is equal to 0. So that means to be able to find what the x-intercept is, I need to substitute y with 0. And then I need to solve the equation for x. And when I solve the equation for x, I end up with 3. X equals 3. So the x-intercept in this situation is 3, 0. Now to find the y-intercept, I know that for the y-intercept, the x value is 0. So in this situation, I have to substitute 0 for x and to try and solve the equation for y. And when I substitute x for 0, I end up with a value of 6. So the y-intercept is 0, 6. So this linear equation has two intercepts. The x-intercept is 3, 0, and the y-intercept is 0, 6. Now let's talk about the forms of linear equations. So the first form is the slope y-intercept form, which is y equals mx plus b. You guys learned about this form in the middle school. M represent the slope of the line, and B represent the intercept, the y-intercept, and we're going to talk about the slope next in the next lesson. Basically, in this form, what we need to do is to isolate the y. Y is isolated. The second form is called the standard form. And in the standard form, we have ax plus by equals c, where a, b, c are numbers. So basically, in this form, we have x and y on the same side. Now let's take a look at this example where we have a linear equation, but the question is asking us to change this linear equation to the slope y-intercept form first, and then to the standard form second. So I'm looking at this linear equation and I see parentheses. One thing we knew that we need to get rid of the parentheses by using the distributive property. So I have 3 times x, which is 3x, 3 times negative 3, which is negative 9, equals y minus 6. Now, as we said before, the main thing in the slope y-intercept form is to isolate the y. So my goal is to have y by itself on one side. So to be able to have y by itself on one side, I have to add this 6. To get rid of the 6, and then I'm going to end up with 3x. Negative 9 plus 6 is negative 3 equals y. So this is what I have. The slope y-intercept is y equals 3x minus 3, where y is isolated. Now, to change the same equation into the standard form, again, I need to distribute. So I have 3x minus 9 equals y minus 6. In the standard form, as we said, we have to have x and y on the same side. So my goal here is to have y move to the other side of the equation with 3x. So I'm going to subtract y from both sides. So I'm going to end up with 3x minus y minus 9 equals negative 6. Now, we know that in the standard form, we don't have constants on with the x and the y side. So we're going to have to get rid of that number by moving it to the other side and adding 9 to both sides. So I'm going to end up with 3x minus y equals 3. So this is the standard form where 3 is A, negative 1 is B, and 3 is C. And that's the standard form. Now let's take a look at this word problem. Mary has a budget for her cell phone bill. The linear equation y equals negative 40x plus 520 represents how much money she has left in her budget, y, after she pays her bill for x number of months. Now, y in this example represents the money in the budget, and x represents the number of months. So let's take a look at the first question. The first question is determine how much money she has left after 3 months. So what we're trying to find is the money in the budget or the amount of money in the budget, which is Y, when we have 3 months. So in this case, I'm going to substitute x with 3 and then solve the linear equation, which will be equal to y equals 400 because negative 40 times 3 plus 520 is 400. So Mary has $400 after 3 months. Now, the second part of the question is to calculate the initial amount of money she has in her budget. Now, we know that the initial amount of money is when the number of months is 0, because at 0 month, this is where she has the most money. This is where she didn't have to spend any money on her cell phone bill. So when x equal to 0, we'll be able to find the amount of money or the initial amount of money she has in her budget. And again, we're going to have to substitute x with 0. And when we substitute x with 0, we end up with y equals 520. So it's $520 in her budget. Um, um, and that's the initial amount of money she had. Now, C is asking us to calculate the number of months she will pay with her budget. So when she finished paying, using her budget, she's going to end up with a balance of 0. So in this case, y, or the amount she has in her budget, will be 0. So to be able to find the number of months, that means I need to solve for x. So this time, I'm going to have to substitute y with 0 and then try and solve the equation for x. And when we do that, we have to subtract a 520 from both sides, which is going to make me end with negative 520 equals negative 40x. And by dividing my negative 40, I'm going to end up with x equals 13. So Mary is going to be able to pay for 13 months using the $520 in her budget.